Let us learn about indefinite integrals. We know that integration is an inverse process of differentiation. So the process of differentiation and integration are inverses of each other. If dy by dx is f of x, say, then y will be integral of f of x dx. If you write the sign of integration, this is an elongated S which stands for summation. We will learn in limit of sums exercise. These are like brackets. If you write the integral sign, it has to be written with respect to which variable you are integrating. And then in between the brackets we write the function. So in between integral and dx we write the function which has to be integrated. This f of x is called the integrand, and this x is called the variable of integration. D by dx of x square is 2x, we know. D by dx of x square plus 3 is also 2x because derivative of 3 is 0. And d by dx of x square minus 1 by 10 also gives 2x. D by dx of x square plus root 3 is 2x. So for so many functions, the derivative is the same, 2x. Now let us write the corresponding integral for this. Integral of 2x dx is equal to, I may write x square, or I may write x square plus 3, or x square minus 1 by 10, or x square plus root 3. So in general, I can write it as x square plus c, and this c is called the constant of integration. Geometrical meaning of integration. Geometrical meaning of differentiation we know. It gives slope of the tangent. Now integral of 2x dx, we wrote it as x square plus c. C can take any real value. If c is 0, x square represents a parabola which passes through 0 origin. If c takes some other value, we get another parabola like this. So this x square plus c represents a family of parabolas. This is x-axis, origin, and y-axis. If I draw a vertical line parallel to the axis of the parabola, here the axis of the parabola is y-axis, and draw tangents to these parabolas at this point where this vertical line intersects, all these tangents will be parallel to each other, whose slopes are 2x. Therefore, this x square plus c represents family of curves. Therefore, the geometrical meaning of differentiation is it gives slope of the tangent, and geometrical meaning of integration is it gives family of curves. Differentiation gives you a unique answer, a unique function, whereas integration gives you a family of curves, because for different values of c we will get different curve equations. Let us see the physical meaning of integration. We know that in differentiation, if you differentiate the distance traveled by a particle, the derivative gives you the velocity, and if you differentiate the velocity, it gives the acceleration, we know. Similarly, in integration, if we integrate acceleration, we get velocity. If velocity is integrated, we get the distance traveled by the particle at time t. And another difference between differentiation and integration is we can find the derivative of a function at a point. For example, when x is equal to 2, we can find the answer. Find dy by dx and we can substitute the value of x as 2. Whereas Integration can be calculated only in an interval, which becomes a definite integral. We already know the formulae for derivatives of some of the functions. So using those formulae which we studied in differentiation lesson, let us write the integration formulae. We have to learn so many methods and so many formulae in this chapter.
Keep a separate notebook to write these formulae and memorize them.
Integral of x raised to n dx is x power n plus 1 divided by n plus 1 plus c, and this formula is applicable when n is not equal to minus 1. Okay, let us differentiate this and see. 1 by n plus 1 is a constant. Differential of x power n plus 1, n plus 1 x raised to n plus 1 minus 1 gives you n. We get this answer, x power n. Why it is not applicable when n is equal to minus 1? Let us apply this formula and see. It becomes x raised to 0 by 0. Division by 0 is not defined. Therefore, this formula is not applicable when n takes the value minus 1. This formula is applicable if you have a linear function of x in place of x. See, in place of x, we have ax plus b, which is a linear function of x raised to n dx. So the same formula we can apply. Ax plus b raised to n plus 1 divided by n plus 1. But remember, we have to divide by the coefficient of x term. Because when we do differentiation, we multiply by the coefficient in chain rule. That's why here we divide. Let us do the differentiation and check. 1 divided by a times n plus 1 is a constant. I am differentiating the function. N plus 1 times ax plus b raised to n plus 1 minus 1 becomes n into chain rule. We have to differentiate the base, which is a. So to cancel this a only, we are dividing by the coefficient of x here. It is a linear function, that is differentiation of that linear function, or I can say coefficient of x. An integral of 1 dx will be x plus c, because differentiation of x is 1, therefore integral of 1 is x. If I have a constant, I can take out the constant and integrate, so it becomes kx plus c. This formula is applicable only for x power n or a linear function of x raised to n. If I have root x power n, I cannot use this formula because this is not a linear function of x. So this formula is not applicable. Now the second formula, integral of cos x dx is equal to sin x plus c. Because differential of sin x is cos x, therefore integral of cos x is sin x. This formula is applicable if we have a linear function ax plus b in place of x. The answer will be sin of ax plus b, but don't forget to divide by the coefficient of x. That is the differentiation of this linear function, and plus c, the constant of integration. If I have integral of cos x square, the formula is not applicable because we have x square, which is a quadratic function, not a linear function of x. So this formula is applicable only when we have x or a linear function of x. For other functions, we cannot apply the integration formulae. Third formula, integral of sin x dx is minus cos x plus c, because differentiation of cos x is minus sin x. Therefore, integral of sin x, I can write the minus sign on the other side, so minus cos x. And this formula is applicable if we have a linear function of x in place of x. So it will be minus cos of ax plus b divided by the coefficient of x and plus c. This formula is not applicable if I have, for example, sine of e power x dx, because e power x is an exponential function, not a linear function of x. Therefore, I cannot apply this formula for such functions. Now, fourth formula, integral of secant square x dx. We know that differential of tan x is secant square, therefore integral of secant square is tan x plus c, and this formula is applicable for secant square of a linear function ax plus b dx, which is tan of ax plus b divided by a and plus c. Next, integral of cosecant square x dx. We know that the differential of cot x is minus cosecant square, therefore integral of cosecant square is minus cot x plus c, and this formula is applicable only when we have a linear function of x in place of this x function. So it is cot of minus cot of ax plus b divided by a and plus c. Sixth formula, integral of secant x multiplied by tan x dx, which is secant x plus c, because differential of secant x is secant x tan x, we know, and this formula is applicable if we have a linear function of x. It is secant ax plus b divided by the coefficient of x and plus c. Similarly, integral of cosecant x cot x dx will be minus cosecant x plus c, and we can apply this formula for linear function of x. Cot of ax plus b dx is minus cosecant ax plus b divided by a and plus c. Now we know the differentiation for all inverse trigonometric functions. So corresponding integration formula we will write now. Integral of dx by root of 1 minus x square. This is sine inverse of x plus c, or we may write minus cos inverse of x plus c also, because differential of cos inverse is minus 1 by root of 1 minus x square, or we know that sine inverse of x plus cos inverse of x is pi by 2. So using that identity we can change sine inverse to cos inverse, and constant terms could be combined. And this formula is applicable even for a linear function of x, that is 1 minus ax plus b raised to 2, which is sine inverse of ax plus b divided by a plus c, or we may write minus 1 by a cos inverse of ax plus b plus c. Next formula, integral of dx by 1 plus x square. We may write the answer in terms of tan inverse of x or cot inverse of x. So this becomes minus cot inverse of x. And the formula is applicable for a linear function of x. So it is tan inverse of ax plus b divided by a plus c, or minus 1 by a cot inverse of ax plus b. I cannot apply the formula if the function is like this. Okay, this formula is not applicable. Don't write this as tan inverse of x square, because this is a quadratic function. In place of x, only linear functions are allowed. then only the formulae are applicable. Let us see the next formula. Integral dx divided by x times root of x square minus 1. This is secant inverse of x plus c or minus cosecant inverse of x plus c. And this formula is applicable for linear function of x also. Ax plus b times ax plus b the whole square minus 1. Secant inverse of ax plus b divided by a. The next formula, integral e power x dx is e power x plus c, because differential of e power x is e power x. This can be applied even if you have a linear function of x, e power ax plus b dx. It is e raised to ax plus b divided by a and plus c. This formula cannot be applied if you have e raised to, for example, sin x dx, because this is a trigonometric function, not a linear function of x. Therefore, this formula cannot be applied here. Integral of 1 by x dx. The formula for this is x raised to n plus 1 by n plus 1 plus c, where n is not equal to minus 1. That is 1 by x. 1 by x means x raised to minus 1. So for x raised to minus 1, the formula is different. It becomes log x, because differential of log x is 1 by x plus c. We write log of absolute value of x, because log function is defined only for positive real values. Log 0 is also not defined. X should be greater than 0. That's why we write the absolute value sign in the answer. And this formula is applicable for a linear function of x. For example, if I have x cubed plus 3, say, I cannot write it as log of absolute value of x cubed plus 3, because this is a cubic expression, not a linear function. Integral a raised to x dx. It is a raised to x divided by log a and plus c. Derivative of a raised to x is a raised to x into log a, multiplied by log a, here divided by log a. And we can use this formula if you have a linear function in place of x, bx plus c. Already a is there, that's why I am taking bx plus c here. So a raised to bx plus c divided by log a and divide by the coefficient of x, which is b. Be thorough with all these formulae. Then only you will find this chapter easier. Otherwise, it's going to be difficult. Let us see some properties of indefinite integrals. We know that differentiation and integration are inverse processes, so they cancel each other. If we have integral f dashed of x dx, here we have integration, here we have differentiation, so they cancel each other. We get the answer f of x and plus c. Integral of f of x plus g of x dx. If you have sum of two functions, we can separate the integrals and write this as integral of f of x dx plus integral g of x dx. Let us take integral of f of x as capital F of x. We have to write one constant of integration for this integration, and let us take the integral of g of x as capital G of x and the constant of integration be c2. and C1 plus C2 can be written as a third constant, C3 or C. So it's enough if you write one constant of integration at the end. If you integrate 2 or 3 terms or more terms, just write one constant of integration at the end after integrating all these terms. Integral k times f of x dx. K is a constant, so we can remove it outside the integral. It becomes k times f of x dx. Let us start exercise 7.1. Find an antiderivative of the following functions by the method of inspection. So let us check d by dx of cos 2x. d by dx of cos 2x is minus sin 2x into 2, the coefficient of x, chain rule. Therefore, d by dx of, bring that 2 to this side, so minus half cos 2x is sin 2x. Therefore, antiderivative of sin 2x, that is integral of sin 2x with respect to the variable x, is minus cos 2x divided by 2, and we have to write the constant of integration plus c. Now let us do the sums directly. Integral of cos 3x dx. Integral of cos is sin 3x, but for integration we have to divide by the coefficient of x and plus c. Question 3. Integral of e power 2x dx. 2x is a linear function, so the formula is applicable. E power 2x, but we have to divide by the coefficient of x and plus c. Question 4. Integral of ax plus b whole raised to 2 dx. That is ax plus b whole power n plus 1 divided by n plus 1. 2 plus 1 is 3, and we have to divide by the coefficient of x, which is a, and plus c. Question 5. Integral of sin 2x minus 4 e power 3x times dx. For subtraction and addition, we can integrate separately each term, and integral of sin 2x is minus cos 2x divided by the coefficient of x minus 4 e power 3x. 3x is a linear function, so the formula is applicable. E power 3x divided by 3 and plus c. For example, if you have e power x square, say, the integral of e power x formula is not applicable because we have a quadratic function here. Only for linear function the formulae are applicable. Question 6. Integral 4 e power 3x plus 1 dx. Addition of two functions, so we can separately integrate each function. 4 is a constant, take it out, e power 3x dx and plus integral of 1 dx. 3x is a linear function, so the formula is applicable. E power 3x and divide by the coefficient of x plus integral of 1 is x, we know, and plus constant of integration. It's enough if you write one constant of integration. As I said, one constant of integration for this plus c2 for this, together we can write it as one constant of integration c. Question 7. Integral x square times 1 minus 1 by x square dx. We don't know how to find the integral of product of two functions. So let us open the brackets. X square minus 1 times dx. Now easily we can integrate. Integral of x square is x cube divided by 3, that is using x power n plus 1 by n plus 1 formula, and integral of 1 is x. I will write two integral terms here. Integral of 1 is x and one constant of integration will do, so plus c. Question 8. Integral ax square plus bx plus c times dx. Remember, if you write the integration sign, you have to write with respect to which variable we are integrating. Dx has to be written equal to, a is a constant, I can remove it outside the integral. So integral of x square dx. Again, b is a constant, it becomes x dx, and c is a constant, integral of 1 dx. Let us integrate. Integral of x square is x cube divided by 3 using x power n plus 1 by n plus 1 formula. B times integral of x is x square divided by 2, that power rule we are using, plus c times integral of 1 with respect to x is x, and plus d, the constant of integration. Already c is there in the answer, so I am using d. d is the constant of integration. Question 9. Integral of 2x square plus e power x times dx. 2 is a constant, so 2 times integral x square dx plus integral e power x dx. Use the power rule, x power n plus 1 by n plus 1 formula, so it becomes x cube divided by 3. And e power x, integral of e power x is e power x, so simple. And plus the constant of integration c. Question number 10. Integral root x minus 1 by root x whole raised to 2 dx. If you have integral of x square dx, we can write the integral as x cube by 3 plus c, and in place of x, if you have a linear function ax plus b, it is applicable. This formula is applicable, but here this bracket, inside the bracket we don't have a linear function, so I cannot use x power n plus 1 by n plus 1 formula. Let me expand this. A square term plus b square term minus 2ab, root x and root x will get cancelled, so minus 2 times dx. Now we will integrate each term. Integral of x is x square divided by 2 using x power n plus 1 by n plus 1 formula. And integral of 1 by x, we have a formula, log of absolute value of x minus 2 times integral of 1 is x and constant of integration plus c. Question number 11. Integral x cube plus 5x square minus 4 divided by x square dx. Division of two functions, we don't know how to integrate, so let us separate the terms. X cube divided by x square is x, and 5x square by x square becomes 5, and minus 4 divided by x square times dx. This is integral of x dx plus 5 times integral of 1 dx minus 4 times integral x raised to minus 2 dx. Now let us integrate. X square divided by 2 using x power n plus 1 by n plus 1 formula. Integral of 1 with respect to x is x minus 4 x power n plus 1 by n plus 1. So minus 2 plus 1 becomes minus 1 divided by minus 1 plus c, which can be written as x square by 2 plus 5x plus 4 divided by x. Question number 12. Integral x cube plus 3x plus 4 divided by root x. Root x can be written as x raised to half. Same method we are going to use. Let us divide each term by x power half. So x raised to 3 divided by x power half is 3 minus half. 3 minus half becomes 5 by 2 plus 3 times 1 minus half, x raised to 1 minus half is half, and plus 4 x power minus half times dx. Let us integrate each term using x power n plus 1 by n plus 1 formula. This becomes x power 7 by 2 divided by 7 by 2 If I write the reciprocal, it becomes 2 by 7. 3 times x power half plus 1 is 3 by 2 divided by 3 by 2, which becomes 2 by 3. And then 4 times x power minus half plus 1 is plus half divided by half will become into 2 and plus c. Therefore the answer is 2 over 7 x power 7 by 2 and plus 2 times x power 3 by 2 and 4 2s are 8 x raised to half and plus c. Question number 13. Integral x cube minus x square plus x minus 1 divided by x minus 1 dx. Here we have division. We cannot integrate it directly. So we will divide by x minus 1 by doing long division, or we may factorize the numerator. Here factorization method is easier. X square is common in the first two terms, 1 is common in the last two terms. Now x minus 1 is a common factor. The numerator becomes x minus 1 times x square plus 1 divided by x minus 1, which could be cancelled. It becomes so easy now. X square plus 1 dx. So we can integrate separately. Integral of x square is x cube by 3 using x power n plus 1 by n plus 1 formula, and integral of 1 is x and plus c, the constant of integration. Question 14. Integral 1 minus x times root x dx. We don't know how to integrate product of two functions. So let us open the brackets and do. 1 into root x is root x minus x into root x. X into x power half. Add the powers, it becomes x power 3 by 2 dx. Root x is x power half. We will use x power n plus 1 by n plus 1 integration formula. So half plus 1 is 3 by 2 divided by 3 by 2 becomes 2 by 3 minus x power 3 by 2 plus 1 is 5 by 2 divided by 5 by 2, which is 2 by 5, and plus c, the constant of integration. Question 15. Again same method we are going to follow. Open the brackets. Root x is x raised to half. So it becomes 3 times 2 plus half is 5 by 2. 2 into x into root x. Add the powers. 1 and a half, which is 3 by 2. 3 times root x. Root x is x power half times dx is common to all these three terms. Let us integrate each term. 3 is a constant. So 3 times integral of x power 5 by 2 using x power n plus 1 by n plus 1 formula. 5 by 2 plus 1 becomes 7 by 2 divided by 7 by 2, which is into 2 by 7. 2 times x power 3 by 2 plus 1 will be 5 by 2 into 2 by 5 plus 3 times x power half plus 1, which is 3 by 2 into 2 by 3, and plus c. Let us multiply these numbers and write the final answer. 6 by 7 x raised to 7 by 2 plus 4 by 5 x raised to 5 by 2 plus 2 times x power 3 by 2 and plus c. Question 16. It's a very simple question. Directly we can integrate each term. 2 is a constant, and integral of x is x square over 2. Minus 3 is a constant, and integral of cos x. Integral of cos x is sin x. Plus integral of e power x is e power x. And plus c, the constant of integration. Question 17. This is also a direct question. 2x square minus 3 sin x plus 5 root x. Root x can be written as x raised to half times dx. Let us integrate each term. 2 times integral of x square is x cube divided by 3 minus 3 times integral of sin x. Integral of sin x is minus cos x. So minus of minus becomes plus cos x plus 5 times, use x power n plus 1 by n plus 1 formula. It becomes x raised to 3 by 2 into 2 by 3 and plus c. Let us multiply and write the last term. It becomes 10 over 3 x raised to 3 by 2 and plus c. Question number 18. Integral of secant x multiplied with secant x plus tan x dx. Let us open the brackets. We get secant square x plus secant x into tan x dx. We have direct formulae for both. Integral of secant square is tan x and integral of secant x tan x is secant x and plus the constant of integration. The main thing is you have to be thorough with all the formulae. Otherwise doing this lesson is going to be difficult. Question 19. Integral of secant square x divided by cosecant square x dx. Let us change this in terms of sine and cos. So secant square is 1 divided by cos square and cosecant square is 1 divided by sine square x. Write the reciprocal of the denominator. We don't have direct integration formula for tan square, but we have for secant square. Let us use the identity 1 plus tan square is equal to secant square. So tan square can be written as secant square x minus 1. Memorize the identity properly. Don't write secant square x plus 1. It is secant square minus 1, which is equal to. Now let us integrate these two terms. Integral of secant square is tan x, we know, and integral of 1 is x and plus the constant of integration. Question 20. Integral 2 minus 3 sin x over cos square x dx. Let us separate the terms. This becomes 2 divided by cos square x dx minus 3 times integral sin x divided by cos square x dx. 2 into integral 1 by cos square is secant square x dx minus 3 times integral sin by cos is tan x and 1 by cos is secant x. We have direct formulae for both. Integral of secant square is tan x. So 2 times tan x minus 3 times integral of secant x tan x is secant x and plus c. Question 21. The antiderivative of, that is, we have to integrate root x plus 1 by root x dx. Root x I can write it as x power half and 1 by root x can be written as x power minus half.
Let's use x power n plus 1 by n plus 1 formula.
Half plus 1 is 3 by 2 divided by 3 by 2, which becomes into 2 by 3, plus x power minus half plus 1 divided by half will become into 2. plus the constant of integration c. The correct subdivision is C. Question 22. d by dx of f of x is equal to 4x cubed minus 3 divided by x raised to 4, such that f of 2 is 0, then f of x is, we have to find f of x. From this, f of x will become integral of 4x cubed minus 3 divided by x raised to 4 dx. I can write this as 4 times integral of x cubed dx minus 3 times integral of x power minus 4 dx. Let us integrate and write. This is x raised to 4 divided by 4, which could be cancelled, minus 3 x raised to minus 3 divided by minus 3, and plus c. Therefore, f of x is x power 4 plus 1 upon x cubed plus c, and we have to find f of 2. Plug in the value 2 in place of x. So 2 raised to 4, which is 16, plus 1 by 2 cube is 8, and plus c. And it is given that f of 2 is 0. Let us take LCM here. 128 plus 1 plus c. Therefore, the value of c is minus 129 over 8. Therefore, f of x is x raised to 4 plus 1 upon x cube minus 129 over 8. So, the correct option is A.